కెమిస్ట్రీ సబ్జెక్ట్లో ప్రతి అంశము కీలకమైనదే. అందుకే గ్రూప్స్ మొదలుకొని అన్ని చాప్టర్లపై కూలంకషమైన అధ్యయనం అనివార్యం. అందుకే మేము కెమిస్ట్రీ సబ్జెక్ట్ బోధనలో అపార అనుభవం ఉన్న R.SATYA గారిచే కెమిస్ట్రీ సబ్జెక్ట్ను బోధింపజేస్తున్నాం. సో ఇక ఏమాత్రం ఆలస్యం చేయకుండా కెమిస్ట్రీ క్లాస్లోకి ఎంటర్ అయిపోదామా? నిన్నటి ఎపిసోడ్లో గ్రూప్స్ టాపిక్కు సంబంధించి 6th A గురించి నేర్చుకున్నాం కదా. ఇవాల్టి ఎపిసోడ్లో గ్రూప్ 7th Aకు సంబంధించిన అంశాలను తెలుసుకుందాం. కెమిస్ట్రీ సబ్జెక్ట్ బోధనలో ఎంతో అనుభవం కలిగిన R.SATYA గారు ఇవాల్టి క్లాస్ తీసుకుంటారు.
Let us look at more questions on elements of 5A, 6A and 7A, the P block. How do halogens react with water? This is a very interesting question. How come? Water, is highly unreactive. In several questions we discussed that the OH bond is very strong, it cannot be broken. If an element can do that, it must be considered to be a champion among elements. Like, it should be considered to be highly reactive. And highly active metals like sodium, what they do is they will displace this hydrogen. In a way, they will kick hydrogen out of water molecule and you end up getting NaOH and of course hydrogen atom. This is a very difficult reaction because OH bond is very strong, it cannot be broken. Therefore, elements like sodium, calcium, they are said to be highly reactive metals. Not many substances react with water. Gold doesn't react with water. If gold reacts with water, gold would not be a very precious metal. So, reaction of a substance with water is a very difficult one, and look how fluorine reacts with water. F2H2O, what happens here is, in the earlier reaction, sodium has just displaced hydrogen, but in this reaction, oxygen is thrown out. Oxygen is kicked out of its own house. Oxygen is thrown out of its own house. So, you end up getting 2HF plus O. So, when fluorine reacts with water, you get oxygen atoms, and it's not necessary that 2 of them combine or 3 of them combine. Therefore, what you end up getting is a very interesting one. Like F2 plus H2O, you get 2HF plus O, single oxygen atom, and you multiply 2F2 plus 2H2O. If 2 fluorines react together, you get 4HF plus O2. It's not necessary that only 2 oxygens combine. Very interestingly, 3 oxygens also will combine. 3F2 plus 3H2O, you end up getting 6HF plus O3, and the net reaction goes like this. It is 5F2 plus 5H2O, you get 10HF plus O2 plus O3. Ozonized oxygen, you get a mixture of oxygen and ozone. Ozonized oxygen. This is a preparation of ozone, one of the methods of preparation of ozone also. So look here, what is the significance of this reaction? Breaking one OH bond itself is a Herculean task, a difficult task. But here, both the bonds are broken. Fluorine is so highly reactive that it breaks both the bonds with both OH bonds. So you end up getting oxygen and ozone, ozonized oxygen. This is how fluorine reacts with water. And look at how the other halogens react with water, namely chlorine. And you should learn that with a comparative study. Look here. FF-HOH, both the bonds are broken here, and chlorine just will break only one bond, Cl, HOH. It breaks just one bond, and you end up getting HCl and HOCl. hypochlorous acid. So what is that you should compare? Here both the OH bonds are broken, oxygen hydrogen bonds, both of them are broken, whereas chlorine could break only one of the bonds. So chlorine is less reactive. Bromine also reacts the same way, means you will be getting HBr and BrOH, same. Bromine, Br2 plus H2O, similar to the above. You get HBr plus HBrO, hypobromous acid, and iodine doesn't react with water at all. So what does it tell you? Fluorine is very highly reactive, chlorine is slightly less reactive, iodine is not at all reactive, at least with water. So reactivity decreases. That is a trend you have to observe. This is how halogens react with water. Now, this is a question given very, very frequently, even in the 2011 IPE exam, and almost every year reactions of ozone happen to be very important. So, let us learn some of the reactions of ozone. I told you in all the reactions, ozone will be converted like this, O2 plus O. It gives you one oxygen atom in all the reactions, and this extra oxygen, I repeat, this is an extra oxygen. O2 is a more stable molecule than ozone. This extra oxygen reacts with whoever comes. For example, PbS plus O3. What is expected? So how does ozone react with PbS? Ozone gives an oxygen, and how many oxygens are taken by sulfur here? PbSO4. So ozone gives only one oxygen, so you need 4 ozone molecules, 4 ozone, each of them will give one oxygen atom only, so that oxygen is transferred here. So here sulfur goes from -2 to +6 oxidation state, means sulfur is being oxidized to a very high extent from -2 to, so this is an oxidizing property of ozone. Why do you say it is going from -2 to +6? Who is going from -2 to +6? It is sulfur. Nothing is happening to lead, Pb. Look here, Pb is +2 here and +2 here also. So here ozone is taking sulfur from a low -2 level to a high +6 level, oxidizing property of ozone. And we saw this reaction also, KNO2 plus O3. What will happen? Nothing will happen to K. Once again get KNO3 plus O2, oxidizing property of ozone. Like this, you can have any number of reactions where ozone is oxidizing others, and sometimes ozone reduces also. BaO2 plus ozone. If you remember, in one of the previous questions we discussed that BaO2 is called barium peroxide. How do you know it's barium peroxide? Barium can only be +2, fixed. Barium has a fixed oxidation state. Therefore, 2 oxygens together they get -2. So when you get -2 on 2 oxygens, I repeat, O2 2 minus, then it is called a peroxide, -1. Each oxygen is getting -1. Therefore, this is barium peroxide. So we know that peroxides, the peroxy bond, O bond is very weak. It will be broken easily. Therefore, that extra oxygen in peroxide, not just this peroxide, hydrogen peroxide, sodium peroxide, any substance that contains O bond, that extra oxygen will go with this extra oxygen of ozone. So you get BaO plus extra oxygen O2 plus O2. So BaO2 is converted to BaO, O3 is converted to O2, and where do you get this O2 from? Extra oxygen, one oxygen from here, one oxygen from here. So what is happening here? Oxygen is going from -1 to -2. You can say here oxygen is reduced from -1 to -2. So one of the reduction properties of ozone. Like that, Ag2O and O3 on slight heating, every time I repeat telling you slight heating. The reason, nobody knows what happens when you heat a substance very strongly. When you give a lot of energy, anything may happen. Therefore, so why do I keep repeating slight heating, strong heating? We don't know what will happen. So you get 2 silver plus O2 plus O2. Why am I writing the 2 O2 separately? This O2 comes from ozone and the other O2, the last O2 comes from the extra oxygen here and the extra oxygen here. You can't call it extra oxygen, it is a very, very weakly held oxygen. So these are the reduction properties, these two are the reduction properties of ozone, reducing properties. One other